Hey everyone, so we are back with another examination of O-Level Chemistry 5070, and today we are going to be solving 2018 October-November variant 1, obviously MCQs. I picked this paper because it had a higher threshold compared to the other years, so let's begin. The first question says, a student titrates aqueous sodium hydroxide, which is an alkali, from burette with dilute hydrochloric acid in a conical flask. After the titration is complete, the conical flask is emptied. The conical flask obviously contained water and salt. What is the correct procedure before the next titration? So obviously you need to empty the content, you need to wash it, and then you need to rinse it with distilled water. So you need to look for the option which says this. So rinse out the conical flask with aqueous sodium hydroxide, no sorry, because otherwise the sodium hydroxide would stick on the walls and then it would affect the volume required for titration, so which is wrong. Rinse out the conical flask with dilute hydrochloric acid, that is again wrong, because then it would stick on the walls of the container, so that is also wrong. Rinse out the conical flask with distilled water, that is only correct, because now the flask is totally clean and then you can add hydrochloric acid from scratch. Question 2 is again, apparently by the looks of it, seems to be from chromatography. It says the results of a paper chromatography experiment are shown. X is an aqueous solution of a salt of group 1 element. Y is an aqueous solution of a salt of transition element. Which row is correct? Larger RF value requires a locating agent. Now if I'm not wrong, X is going to be a colorless solution, and transition elements are generally colored solutions. So it is going to require locating agent. X is going to require a locating agent, and apparently Y has a higher RF. It is almost 0.8 or 0.7. So RF value is higher for Y, and X is going to require a locating agent because solutions of group 1 metals are colorless. Question 3 says, a substance dissolves in water to form a colorless solution. This solution reacts with aqueous silver nitrate in the presence of dilute nitric acid to give a yellow precipitate. Now you should remember that yellow precipitates with silver nitrate are formed only for iodide ions, because iodide ions, whenever they react with silver ions from silver nitrate to produce silver iodide yellow precipitates. And we have to look for iodide, so it could be C, it could be A. But in the beginning they said it's a colorless solution. So if I picked iron to iodide, it's not colorless because iron to salts are not colorless. So it has to be A for apple because calcium salts are colorless and then they give yellow precipitate if iodide ions are present. Question 4 says, which statements are correct? The volume of a gas at constant pressure increases as the temperature increases. That is true. When you increase the temperature, the pressure also increases, because then the gas molecules are going to have higher kinetic energy. They're going to collide more, not only among each other, but they're also going to collide with the walls of the container. The rate of diffusion of a gas increases as the temperature increases. That is also true, because higher temperature means higher kinetic energy, which means more velocity for the particles, which means they're going to collide, they're going to move, they're going to spread more quickly. The pressure of a gas at constant volume decreases as the temperature increases. That is not true, because when the temperature increases, the volume should also increase. That is what Charles' law tells us. So it means 1 and 2 are correct, but 3 is wrong. So 1 and 2 only are correct. Question 5 is, which row shows the number of particles in this sulfur particle? So let's see. It has 16 protons because the subscript on the left side says 16. It is the number of proton. The atomic mass is equals to 34. So how many neutrons? Neutron is equals to atomic mass minus atomic number. So it has 34 minus 16, which means 18. So 18 neutrons, 16 protons. So if I'm not wrong, option B seems to be correct only. How does it have 18 electrons? Because it has minus 2 charge. So it has 2 extra electrons, and that is why it has a minus 2 charge on it. Question 6 says, which substance has a giant covalent structure at room temperature? So giant covalent structure is not methane because it is limited number of atoms. Sand, which is also known as silica, has a very large number of atoms joined together by covalent bonds, so that is covalent. Sodium chloride is ionic, not covalent. Water is again simple covalent. They want giant covalent, which is only sand, also known as silica or silicon dioxide. Magnesium oxide has a higher melting point. Magnesium oxide is MgO. It is used to line the inside of furnaces that operate at high temperatures. Why does magnesium oxide have a higher melting point? So let's recall that magnesium oxide is ionic compound with ionic lattice. Why does magnesium oxide have a higher melting point? It has metallic bonds. No, sorry. These are ionic in nature. It has strong forces between its molecules. No, sorry. There are no molecules. We don't use the word of molecules over here. We use the word of ions over here. It is a simple molecular substance. No, sorry, again, not simple, not molecular. It is an ionic compound, which is the only true statement over here. What is the dot and cross diagram of NCl3, nitrogen trichloride? So nitrogen should be in the middle, which is the case for all the options. There should be 3 chlorine atoms. There should be 1 covalent bond each with 1 chlorine, like with each chlorine atom there should be 1 covalent bond. You should remember that nitrogen is in group 5. So nitrogen has 5 electrons in the last shell. So nitrogen not only has 3 electrons involved in bonding, but it has 2 electrons not involved in bonding, which we say lone pair, or we say them unbonded electrons. So let's look at the structure. A is wrong because they haven't represented the lone pair of nitrogen, the unbonded electrons. D is also incorrect because again the nitrogen lone pair is not represented. It could be B or it could be C. Now when we look at structure B, the problem is that with each chlorine they have represented only 2 lone pairs. Now I want you to remember that each chlorine has 7 electrons in outermost shell, which means that if 1 electron is involved in bonding, there should be 6 more. So there are 2 more, then there are 4 more. What about the other 2? So it should have 6 more. So option C is correct because each chlorine atom is represented with 6 electrons unbonded, or you can say 3 lone pairs. 3 lone pairs. So option C is correct. Question 9 says, 2 properties of a metal are given. It is malleable, it conducts electricity. Which of the properties are due to the layers of positive ions being able to move? So positive ions move, and that gives malleability. It makes them malleable because the layers are sliding over each other. So only statement 1 is connected with malleability or the sliding. Statement 2 is connected with the mobility of electrons. So you don't have to worry about the malleability when it comes to the electrons. Only statement 1 is connected with malleability, or you can say the sliding of the layers present over here. Question 10 says, what are the relative formula masses of 1 mole of solid magnesium and 1 mole of gaseous chlorine? So I'm very sure that when it says 1 mole, the mass of 1 mole is known as the molecular mass, or you can say the atomic mass. The actual word is going to be the molar mass. So for magnesium, which is Mg, it is 24. But people often get confused for chlorine. Chlorine is not Cl, it is Cl2, which means 35.5 times 2. So for magnesium it's 24, but chlorine is 71. So chlorine is not 35.5. That is the atomic mass of chlorine atom, but gaseous chlorine is actually a diatomic molecule, which means that it's going to be having 71 as the mass. Question 11 says, complete combustion of a hydrocarbon produces only carbon dioxide and water. It means that hydrocarbon obviously contains hydrogen and carbon atoms. You're going to get carbon dioxide and water. it's gonna give you this is actually pentane over here. Let's see, they're pentane. That's pentane represented in the equation. When 0.1 mole of hydrocarbon is completely combusted, which volume of carbon dioxide measured at room temperature and pressure is produced? I want you to remember that the molar ratio over here is 1:5. So 1 pentane gives you 5 moles of carbon dioxide. So 0.1 will give you how much? You can do the cross multiplication. It's going to give you 0.5 mole carbon dioxide. Now that is the mole of the carbon dioxide. That is not the volume. If you remember, the formula for volume is mole times 24 for decimeter cube. So 0.5 times 24 is going to be 12 decimeter cube. That is the answer over here. Question 12 is, what is observed when during the electrolysis of aqueous copper 2 sulfate using carbon electrodes? I want you to make the window. For aqueous copper sulfate, we have hydrogen ions and OH ions because of the water, and copper 2 ions and sulfate minus 2 ions because of the CuSO4. Now, among copper and hydrogen ions, copper will be discharged to copper atoms at the cathode because copper is lower in the electrochemical series, while among sulfate and hydroxide ions, you will get the discharge of hydroxide ions. They're gonna make oxygen gas at the anode because again OH is lower in the electrochemical series. Hydrogen ions and sulfate ions are gonna remain in the solution. So it says a pink solid is deposited on the anode. That is not true because on the anode you're getting oxygen gas. So that is not true. There's no such thing as pink solid being made on the anode. Bubbles form on the negative electrode. Negative electrode is cathode, and as we just saw, cathode is receiving copper. So again, statement option B is also not true. The color of the solution fades. It is true because copper ion concentration decreases, and since copper ions are decreasing in their concentration, the color will become less blue. The intensity of the blue is going to decrease. For the confirmation, let's read option D. The negative electrode becomes smaller. That is not true because the negative electrode is cathode, and cathode is being deposited with newly formed copper. So the mass is increasing, not decreasing. So option C for cat is the only correct option here. Let's see question 13. Electrolysis is used to plate a metal statue with silver. The statue is an electrode in a suitable electrolyte. Which row is correct? So this is a question regarding the electroplating. If you have watched my video, you would remember that electroplating involves obviously cathode made by the material that needs to be plated, and anode is the expensive metal. The statue has to be the cathode. It is the material that has to be silver plated, so statue should be cathode. So option C and D are wrong. The electrolyte has to be aqueous. Silver chloride is obviously wrong. Option C is again wrong. Why? Because silver chloride is insoluble salt. So silver chloride is insoluble salt. It is not a good electrolyte. So the only correct option over here is B for ball, because silver nitrate conducts electricity and the material that has to be electroplated is made into the cathode over here. Let's go for question 14. Which statements about endothermic reactions are correct? Energy is absorbed. Yes, that is true because endo means absorbing heat energy. Thermic means heat. Energy is released. No, that is obviously not true because statement 1 is correct, 2 is wrong. The temperature of the reaction mixture falls. That is true because all the heat has been absorbed. And since heat is absorbed by the system, the environment becomes cooler. The temperature of the reaction mixture rises. That is not true. So 1 and 3 are the only correct statements. Option A for apple. The equation represents the reaction between two gases, X2 and Y2, to form compound XY. The energy profile diagram for the reaction is shown. Which statement about this reaction is correct? The activation energy of the reaction is equal to E. That is not true because the activation energy begins from the level of reactants to the top, not from the level of products. The enthalpy change for the reaction is equal to E. That is again not true. Enthalpy change goes from reactants to products. So that is again not true. The reaction is exothermic. That is true because the energy of products is lesser than the energy of reactants. Products are on a lesser level, on a lower level than compared to the reactants, so they're going to release the extra heat. That is true. The total energy needed to break the bonds is greater than the total energy needed to form the bonds. That's not true because this reaction is categorically exothermic. It is gonna release more as compared to absorption. Because in exothermic reactions, the energy released to make the bonds is higher. Form the bonds is actually released, and that is higher over here, not lower. Question 16 says, the equation shows the reaction for the manufacture of ammonia, which is also known as the Haber process. Which change will decrease the activation energy of the reaction? Activation energy is only governed by the catalyst, so you need to add a catalyst if you need to decrease the activation energy. Nothing else affects the activation energy. Let's go for question 17. When bismuth 3 chloride is added to water, a reaction occurs and a white precipitate of BiOCl is formed. Which changes increase the mass of the white precipitate formed? The white precipitate is on the right hand side of the equation. So if you push the equilibrium to the right side, only then you're going to receive more white precipitates. If you add more water, water is on the left hand side, it will shift the equilibrium. It will shift the equilibrium to the right side. So that is true. It will make more white precipitates because the precipitates are received on the right side. Adding aqueous sodium hydroxide. If you add sodium hydroxide, the sodium hydroxide will neutralize the HCl. As the HCl is neutralized, it will decrease the concentration of HCl, and since the concentration of HCl decreases, the equilibrium will shift to the right again. So again the equilibrium will shift to the right because HCl is being neutralized, the concentration of HCl decreases and equilibrium goes to the right side. Adding dilute hydrochloric acid, no, that is not true, because if you add HCl is on the right side, it could shift the equilibrium to the left. So statement 3 shifts equilibrium to left. So 1 and 2 will help to push the equilibrium to the right side, but 3 will not. So 1 and 2 are going to make more white precipitates. Question 18. Calcium carbonate reacts with dilute hydrochloric acid to produce carbon dioxide. The carbon dioxide is collected using the apparatus shown. The reaction is done 4 times. For each reaction, 25 gram calcium carbonate and an excess of hydrochloric acid is used. Which reaction mixture fills the gas syringe with carbon dioxide in the shortest time? So it means the fastest reaction. They want the fastest reaction. And now since calcium carbonate is the limiting reactant, the reaction largely depends on the calcium carbonate. Lumps of calcium carbonate with 1 mole per decimeter cube acid, lumps of calcium carbonate with 2 moles. So 2 mole has a higher concentration, so right now my vote is for option B. Powdered calcium carbonate is available, so lumps have smaller rate of reaction because they have less surface area, but option C and D have powdered, so they are better with more concentration. So this is again concentration is higher for option D D for doctor should be the right option because higher concentration, and then powdered means more surface area. Let's go for question 19. Many reactions involve oxidation and reduction. Which statement is correct? Acidified manganate 7 ions change color from colorless to purple when reduced. No, that is not true. It is the opposite way. It is the other way around, purple to colorless. All reactions that involve oxidation also involve reduction. That is very true because redox reaction always happen simultaneously. During a reaction, oxidizing agents lose electrons. No, sorry. Oxidizing agents reduce themselves. And since they reduce themselves, they gain electrons. All the oxidizing agents always reduce themselves. Reduction is the loss of hydrogen. No, sorry. Reduction is actually the gain of hydrogen. It is also given in my second video in the redox playlist about how reduction is defined. So option B is correct. Let's go for question 20. 3 separate mixture of a solution and solid are made as shown in the table. The mixtures are warmed. In which mixtures does gas form? So when ammonium chloride is mixed with alkali, it produces ammonia gas. If you remember, ammonium salts give ammonia gas with alkalis. Ammonium salts give nothing with acids, so they don't react with acids, they just dissolve in acids, only dissolve. Metals like magnesium react with sulfuric acid to produce hydrogen gas. So it should be gas in column number 1 and 3, but not in column 2. So B for Barrows is the answer. In the next video, we'll jump from question number 21 to the rest of the questions. Stay tuned, guys. Thanks.